Welcome back to week 2 of our IGCSE Chemistry revision. This session covers bonding, stoichiometry, and energetics with rates of reaction. These topics are important because they link structure with properties and calculations with practical experiments. Understanding them provides the foundation for solving exam questions across chemistry. Let's begin with bonding. There are three main types of chemical bonding. Ionic bonds involve electron transfer between metals and nonmetals, forming strong electrostatic attractions. Covalent bonds involve sharing electrons between nonmetals, creating molecules or giant structures. Metallic bonding consists of positive metal ions embedded in a sea of delocalized electrons, allowing metals to conduct electricity while remaining malleable. Bonding also explains substance properties. Ionic compounds have high melting points due to their strong electrostatic forces, and they conduct electricity only when ions are mobile in molten or aqueous states. Simple covalent molecules have extremely weak intermolecular forces, giving them low melting points. However, giant covalent structures are exceptions to this, with examples being diamond, which is extremely hard and non-conductive, and graphite, which conducts electricity due to the presence of delocalized electrons. Balanced equations are vital because they respect the conservation of mass. Each side must show the same number of atoms. With AR and MR, we can calculate formula masses, then apply mole ratios to work out reactant or product quantities. Stoichiometry connects symbolic equations with measurable amounts in real experiments. A mole represents 6.02 times 10 raised to the power of 23 particles, and 1 mole of any substance has a mass equal to its relative mass in grams. Use N is equal to M over Mr to calculate. For gases, remember, 1 mole occupies 24 dm cubed at room conditions. Always check and convert units in exam questions. To find empirical formulae, convert masses or percentages to moles, divide each by the smallest value, and write the simplest ratio. The molecular formula is a multiple of the empirical formula, found by comparing empirical mass with MR. This method is common in exams, so practice plenty of examples. Reactions can either be exothermic or endothermic. Exothermic reactions, like combustion, release energy, raising surrounding temperature. Endothermic reactions, however, like thermal decomposition, absorb energy, lowering surrounding temperature. We measure energy changes using calorimetry and calculate them using bond energies. Energy profiles in exams show reactant and product energy levels clearly. Learn common examples carefully. To calculate enthalpy change, use bond energies. Write delta H is equal to bonds broken minus bonds formed. Breaking bonds absorbs energy. Forming bonds releases energy. If the total is negative, the reaction is exothermic. If positive, it's endothermic. Always show calculations step by step in exams to gain method marks, even if incorrect. Collision theory explains rates. Higher temperature gives particles more energy and frequent energetic collisions. Higher concentration or pressure means more particles per unit volume, increasing collision frequency. Greater surface area exposes more reactive sites, speeding up reactions. Catalysts provide an alternate pathway with lower activation energy, so collisions are more successful. There are several methods to measure reaction rates. We can track mass loss if gas escapes or collect a gas volume with a syringe. Precipitation reactions can be timed visually, such as cross disappearing beneath a cloudy mixture. On graphs, a steeper slope means faster rate, while leveling indicates completion. To recap, we studied three key areas. Bonding explains why substances have particular structures and properties. Stoichiometry uses balanced equations and moles to calculate reactant and product quantities. Energetics distinguishes exothermic and endothermic reactions, while rates of reaction show how fast reactions proceed and how conditions affect them. Together, these units connect theory with practice. Thank you.